Hi guys, welcome back to my geometry tutorials. Today I want to go over parallel lines in more depth than I did in my last video. So let's jump right in. Let's start off with the perpendicular line theorem, which will be used to prove some properties about parallel lines. So consider a line, so let's call it line 1, and a point not on line 1, so point P, and both lie in the same plane. Only one line can be drawn through the point P, and that's perpendicular to line 1. So there's only one line 2 here that can be drawn through P, and that will intersect line 1 at a right angle. So how come more than one perpendicular line? Why can't we draw more than one? Well, let's assume to the contrary that there are two lines, line 2 and line 3, that both can be drawn through point P and that are perpendicular to line 1. Then since line 1 and line 2 are both perpendicular to line 1, then angle 1 here is going to be a right angle, and angle 2 here is going to be a right angle. Why? Because perpendicular lines meet at right angles, right? So, but if we look at this figure here, we have this, we get this triangle PBC, right? So angle 1 is actually an exterior angle for this triangle, right? And 2 is a non-adjacent interior angle, right? So angle 2 is here, this one that has a vertex C, right? So by the exterior inequality theorem, exterior angle inequality theorem, the measure of angle 1 is going to be greater than the measure of angle 2. Well, since we assume that line 2 and line 3 are both perpendicular to line 1, then angle 1 and angle 2 are both right angles, so they both would measure 90 degrees, right? But this can't be, right? Since measure 1 has to be greater than measure 2. You can't have measure 1 is equal to measure 2 and, this inequality at the same time. So that gives you a contradiction. So we cannot draw more than one perpendicular line through point P, and that is perpendicular to line 1. So now we're going to go over the parallel line postulate, and we're going to do the setup in the same way as we did for the perpendicular line theorem. So we're going to consider a point, so point P, in a line 1, and both lie in the same plane. We're also going to assume that point P is not on line 1 because that's just a trivial case. So this postulate says that only one line can be drawn through the point, and that is parallel to the other line. So in other words, we can draw only one line, call it line 2, that goes through P, and that's parallel to line 1. And we want to know why more than one parallel line can't be drawn through P, and that's parallel to line 1. So we can do a proof by contradiction again. So let's assume to the contrary that there are two lines, line 2 and line 3, that pass through point P and that are both parallel to line 1, right? Well, since we have point P here, which is the intersection of line 2 and line 3, if we look at line 1, we can draw, by the perpendicular line theorem, there is one line that goes through point P, and that is perpendicular to line 1. I'll call that line 4, right? But we know that, I think I went over this in my last video, if two lines are parallel and one of them is perpendicular to a same line, then the other one's can be also perpendicular, right? So what this means is that we would have line 2, because line 2 and line 3 are assumed to be parallel to line 1, then line 2 would be perpendicular to line 4, and line 3 would also be perpendicular to line 4, right? But that's impossible. You cannot have two lines that are both perpendicular um, to a point, right? Because there's only one such line that will be perpendicular, which we went over in the earlier example, right? So it's a contradiction. So we cannot actually have more than one line that's passes through P and that's parallel to line 1. So I'm going to move on to alternate interior angles and parallel lines. So this is kind of what we did in the last video, but I'm doing kind of like the reverse now. So when a transversal intersects two parallel lines, each pair of alternate interior angles are congruent, right? So last time we showed if we could establish that alternate interior angles were congruent, then the lines are parallel. So now we're doing the opposite. If we know that the two lines are parallel, then each pair of alternate interior angles are going to be congruent. So I'm going to use that to derive some more properties. So like alternate exterior angles and parallel lines. Let's take a look at this. So we have line 1, line 2, and a transversal. And angle 1 is going to be an alternate exterior angle to angle 2, right? They're both in exterior region. They're not between line 1 and line 2, and they're on opposite sides of the transversal, right? So what I'm going to do, so we're given that line 1 is parallel to line 2, and we want to prove that angle 1 is congruent to angle 2. Well, I'm going to list these angles here, angle 3 and angle 4, right? And we write down what we're given. Line 1 is parallel to line 2. And these are vertical angles, right? Angle 2 and angle 4. And angle 1 and angle 3 are also vertical angles, right? And we know vertical angles are congruent, so we can immediately write down that angle 4 is congruent to angle 2, and angle 3 is congruent to angle 1. But since we know that line 1 is parallel to line 2, then we use our theorem that if a transversal intersects two coplanar parallel lines, coplanar means lying in the same plane, then alternate interior angles are going to be congruent. So we know that angle 3 and angle 4 are alternate interior angles. Why? Because they're both in the interior region between line 1 and line 2, and they're on opposite sides of this transversal. So we know that angle 3 is congruent to angle 4. So if we look at this statement 3 and statement 4, angle 1 and angle 4 are both congruent to the same angle 3. So that means that they're both congruent to each other. Angle 1 is congruent to angle 4. Angles that are congruent to the same angle are congruent to each other. And this parentheses with the numbers just shows which statements I'm using to establish that, right? If we look at statement 2 and 5, so angle 4 is congruent to angle 2, and angle 1 is congruent to angle 4, then angle 1 and angle 2 are both congruent to the same angle, angle 4, so they're congruent to each other. Angle 1 is congruent to angle 2. Same reason, angles congruent to the same angle are congruent. But angle 1 and angle 2 are exterior angles, right? So we just proved if line 1 and line 2 are parallel, then a pair of alternate exterior angles are going to be congruent. What about corresponding angles? Well, let's have these two corresponding angles, angle 1 and angle 3, right? They're corresponding because they're both on the same side of the transversal, the left side here, and one's in the exterior region and one's in the interior region, right? The interior between the space between line 1 and line 2. And I'm going to draw this angle, angle 2, which is a vertical angle of angle 1. So we're given that line 1 is parallel to line 2, and we want to prove that angle 3 is going to be congruent to angle 1. So I write down what we're given. Line 1 is parallel to line 2. Angle 2 and angle 3 by the figure are going to be alternate interior angles, right? Both in the inner region and on opposite sides of the transversal. And we know if line 1 is parallel to line 2, then if a transversal intersects two coplanar, actually parallel lines, so I'm sorry about that. Let me just make that kind of change. Alternate interior angles are going to be congruent. So angle 2 is going to be congruent to angle 3, right? But we know that angle 2 is congruent to angle 1, right? Because vertical angles are congruent. So angle 1 and angle 3 are both congruent to the same angle, angle 2. In other words, they're going to be congruent to each other. So angle 3 is going to be congruent to angle 1, because angles that are congruent to the same angles are congruent. So since angle 3 and angle 1 are congruent, we have, if line 1 and line 2 are parallel, then corresponding angles are going to be congruent, right? Okay, so let's do some more on angles and parallel lines. So here we have line 1 is parallel to line 2, right? And we want to prove that angle 1 is supplementary to angle 2. So angle 1 and angle 2 are not corresponding angles because they're both in the interior region, right? Remember, corresponding angles are both on the same side of the transversal, like these two angles are, but one has to be in the exterior region and one's in the interior region, right? So let's write down what we know. Line 1 is parallel to line 2. I'm going to create angle 3 here, and angle 1 and angle 3 are going to be alternate interior angles, right? They're both in the interior region and on opposite sides of this transversal. So we know if a transversal intersects two parallel lines, alternate interior angles are congruent. So angle 1 is going to be congruent to angle 3. And we know from this figure that angle 2 is supplementary to angle 3. Why? Because the sum of the measures of supplementary angles is 180 degrees. And a straight line measures 180 degrees, right? So if we look back at statement 3, we see that measure of angle 1 is equal to measure of angle 3, right? Because if two angles are congruent, then the measures are equal. And we know from statement 4, measure of angle 2 plus measure of angle 3 is equal to 180 degrees by the definition of what supplementary angles are, right? So what happens if I substitute measure 1 into 6 here? Then we get measure 2 plus, instead of measure 3, we get measure 1 because they're both equal. It's equal to 180 degrees. So we get this relation here, right? And 7. So in other words, angle 1 is supplementary to angle 2, right? Because the sum of the measure of angle 1 and the measure of angle 2 is going to be 180 degrees. So we've established that if line 1 is parallel to line 2, then angle 1 is supplementary to angle 2. Okay, so let's do some more on angles and parallel lines. So let's look at this. Line 1 is parallel to line 2, and line 3 is perpendicular to line 1, and we want to prove that line 3 is also perpendicular to line 2. So we can write down what we know here, and then I set up these angles, angle 1, 2, and angle 3, right? So angle 1 and angle 3 are vertical angles, so they're congruent. And angle 2 and angle 3, I picked them to be alternate interior angles. Why? Because they're in the interior region between line 1 and line 2, and they're on opposite sides of the transversal. What's the transversal in this case? Line 3. So if line 1 is parallel to line 2, then angle 3 is going to be congruent to angle 2. Why? Because if a transversal intersects two parallel lines, alternate interior angles are congruent. But if we look at statement 3 and statement 5, both angle 1 and angle 2 are both congruent to the same angle, angle 3. And we know angles that are congruent to the same angle are congruent. So angle 1 is going to be congruent to angle 2. We know since line 3 is perpendicular to line 1 that angle 1 is going to be a right angle, right? Because perpendicular lines meet at right angles. And a right angle measures 90 degrees, right? But if we look at statement 6, angle 1 is congruent to angle 2, well, what does that mean? That means that the measure of angle 1 is going to be equal to the measure of angle 2 by the definition of congruence, right, for statement 6. And since we know that measure of angle 1 is 90 degrees, well, the measure of angle 2 is going to be 90 degrees, right, by substitution. In other words, angle 2 is going to be a right angle, because a right angle measures 90 degrees. And since this is a right angle here, then line 3 is going to be perpendicular to line 2, because two lines intersecting at right angles are perpendicular. I'm going to go over this last one before we do a few problems. So let's take a look at this setup. Line 1 is parallel to line 3, and line 2 is parallel to line 3. And we want to prove that line 1 is parallel to line 2. So let's write what we know, what's given. And I picked these angles in such a way that angle 1 and angle 4 are alternate interior angles. If we ignore line 2 and these angles here, if we just look at line 1 and line 3, then angle 1 and angle 4 are alternate interior angles, right? Because they're both in the interior region between line 1 and line 3, and then the opposite side of the transversal, which we're going to take as line 4. If we know that line 1 is parallel to line 3, then angle 1 is going to be congruent to angle 4, because if a transverse intersects parallel lines, alternate interior angles are congruent. Okay, if we look at line 2 and line 3, and line 4 is a transversal, then this angle 3 and angle 4 are going to be alternate interior angles because they're both in the interior region between line 2 and line 3, and we have the same traversal, line 4, and angle 3 and angle 4 are both on opposite sides, right? And we know that line 2 is parallel to line 3, so alternate interior angles are going to be congruent for the same reason I used about in statement 4 here. And I have this angle 2, right? And these are vertical angles, angle 3 and angle 4. So we established that angle 3 is congruent to angle 2. And since we know from statement 6 and statement 7 that angle 4 and angle 2 are both congruent to the same angle 3, they're going to be congruent to each other, right? So angle 4 is congruent to angle 2. And we use the fact that angles that are congruent to the same angle are congruent to each other. Now I'm going to look at statement 4 and statement 8. So angle 1 is congruent to angle 4, and angle 2 is congruent to angle 4. So angle 1 and angle 2 are both congruent to the same angle 4. So they're congruent to each other. So angle 1 is congruent to angle 2. Angles that are congruent to the same angles are congruent. And since if we look at angle 1 and angle 2, right, they're alternate interior angles for line 1 and line 2, right, because they're both in the interior region and on the opposite side of this transversal line 4. So we know that line 1 is parallel to line 2. So we use the justification we used in the last video. When a transversal intersects two lines, if alternate interior angles are congruent, then the lines are parallel. That's different than what we did in statement 4, right? Because we knew there were parallel lines, and then we concluded that the angles were congruent, right? Here, if we know that angles are interior angles are alternate interior angles are congruent, then the lines are parallel. Okay, let's go over a few problems. So all this stuff, I know it was a lot of work to go over it, and I really encourage you to go over the last few slides, because instead of memorizing theorems, you can actually derive them, and it's not too hard to actually establish why these different theorems hold. But let's actually do some more kind of regular problem solving. So we're given that line AB is parallel to line CD, and that segment AB is congruent to segment CD, and we want to prove that segment AE is congruent to segment DE. So I write down what we're given, and if we look at, so AB looks like a segment, right? And CD looks like a segment. You can think of them as segments, but segments are subsets of a line, right? So if we just extend, the segment in both directions, then we get the line, right? So if we think of these as lines, then this region, where E is, and this inside of both of these triangles is going to be in the interior region formed by these two parallel lines, right? And if we take AD as a transversal, right, then angle BAE, this angle here, is going to be an alternate interior angle with angle D right here, right? And since these two lines are parallel, then alternate interior angles are going to be congruent. So angle BAE is congruent to angle EDC, right? And then we can apply the same process using the transversal BC instead of AD, right? So we know that ABE, this angle, and ECD, this angle here, alternate interior angles, right? Using a transversal as BC, because they're both inside between these two lines AB and CD, and if we take BC as the transversal, then these angles are obviously on the opposite side, right? So they're both interior angles, and they're congruent since the lines are parallel. So when we look at triangle EAB and triangle EDC, well, we know that two pairs of angles are going to be congruent, right? And we also know that segment AB is congruent to segment CD, right? So we can use ASA, angle side angle, to show that triangle EAB is congruent to triangle EDC. So I wrote down that segment AB is congruent to segment CD. You could also write that a segment AB is congruent to segment DC if you want, if it helps you kind of order it better in your mind. I mean, it doesn't really matter which order you put it for this, because they both mean that the length of the segments are the same, so it doesn't really matter which direction you take it. But if it helps you remember it, you can just flip this around to segment AB is congruent to segment DC. But in any case, we have that these two triangles are congruent, so that corresponding parts of congruent triangles are congruent. So segment EA and segment ED are corresponding parts for these triangles, so they're both congruent. And so we proved that segment EA is congruent to segment ED. So if we just swap the letters here, we get segment AE is congruent to segment DE. It doesn't really matter because, like I said before, congruence between segments is going to mean that the segments have both the same length. So it doesn't really matter which direction you take it, it's always going to be the same length. So if that helps you remember it a little bit better, then that's fine. But let's move on to the next problem here. So we're given this triangle, and we're given that angle 1 is congruent to angle 2, and that segment AB is parallel to line CD. And we want to prove that this triangle is isosceles. So write down what we're given. Angle 1 is congruent to angle 2. And we're given that segment AB is parallel to line CD. Well, if the segment is parallel to a line CD, then the line, because segment AB is just a subset, right, of line AB, right? We just extend it, but that doesn't affect it being parallel to line CD, right? It just stays the same. So we can just write down that line AB is parallel to line CD. I'll just write a segment as a subset as a line is the reason. So if we look at angle 1 and angle CAB, right? So imagine we extend this line here. Well, these two angles are going to be in the interior region between line CD and line AB, right? And if we consider transversal AC, these angles are on the opposite side of the transversal, right? So we can do the same for angle 2 and angle CBA, right? Using BC as a transversal. They're alternate interior angles, right? Because they're both between these two lines and they're on opposite sides of the transversal BC. At any rate, we know that line AB is parallel to line CD, right? So we know that if a transversal intersects two parallel lines, then the alternate interior angles are going to be congruent. So angle 1 is congruent to angle CAB, and angle 2 is congruent to angle CBA. And we know that angle 1 is congruent to angle 2, right? So these two angles are congruent. So then these two angles are going to be congruent. Angle CAB is congruent to angle CBA because angles that are congruent to congruent angles are congruent. And then we can just use the fact that if we know these two angles are congruent, then in a triangle, if you have two congruent angles, then the sides opposite these angles are going to be congruent as well. So segment AC is going to be congruent to segment BC. And what is an isosceles triangle? Well, an isosceles triangle is a triangle that has at least two congruent sides, right? So if we know it has two congruent sides, then it's a isosceles triangle. So ABC is isosceles. Here's the last problem. I know it's been a long kind of video, but there's a lot of stuff to kind of cover. So let's take a look at it. So we have, this is actually called a trapezoid, this ACDF figure here. So we're given that angle DAB, so this angle, is congruent to angle FCB, this angle here. We're given that segment AD is congruent to segment CF, that B is the midpoint of segment AC, and that E is the midpoint of segment DF. And we want to prove that segment BE is perpendicular to segment DF. So how are we going to do that? So we write down what we're given. We're given these four things, right? So I know a midpoint divides a segment into two congruent segments, right? So segment BA is going to be congruent to segment BC, right? And we know that segment AD is congruent to segment CF, and this angle A is congruent to angle C over here. So we can apply side angle side to statement 5, statement 1, and statement 2. So, you know, this side, angle, this side, angle, this side. So we get these triangles BAD and triangle BCF are congruent. And we know that congruent parts of congruent triangles are congruent, so segment BD is congruent to segment BF. Well, we also know that E is the midpoint of DF, right? So we know that segment ED is congruent to segment EF, right? Because the midpoint divides a segment into two congruent segments. And since we know that, well, we know that 2 points that are both equidistant from the endpoints of a segment, so the segment DF, so these two segments are equidistant, right? So if we look at, BD is congruent to BF, right? And ED is congruent to EF, then those 2 points determine the perpendicular bisector of the segment DF, right? So we know that line BE is a perpendicular bisector of segment DF, right? So I didn't actually write it out, but if it's a perpendicular bisector, then it has to be perpendicular, right? So we know that segment BE, which is a subset of line BE, is going to be perpendicular to segment DF. So this was a long video, and I have nothing more tonight, but please look this over. I went over a lot of these proofs because I think it's easier in the long run to kind of understand how to derive different properties instead of just like memorizing them. So definitely look over these examples, and you can always play it over and look over the proof and try it over, even if you don't understand it the first time. So I want to thank you guys for watching my videos, and I hope to see you during my next video. Okay, have a good night, everyone. Bye.